Hi everyone, a warm good evening, and I am Z Prudvi. I come from EC Electronics and Communication Department. My student ID is 2440100491, and here goes my continued alternative assessment 2 of digital circuits and design. And my topic for the assessment is excitation tables and timing diagrams for T flip-flops. So, begin with that. We'll begin with that. T stands for the a T is a toggle flip-flop. It's a type of flip-flop that toggles its output when the input t is equals to 1 and holds the previous value when the t is equals to 0. It is often derived from a Z flip-flop with inputs tied together. Obviously, then we'll be having clock in a flip-flop. Uh, the T flip-flop is like it toggles when the output is when the input is t and holds the previous value when t is equals to 0. So it is almost same as Z flip-flop. So the T flip-flop characters are like Q, the next state, which is basically termed as n plus 1. The current state is defined as just n. So this table shows how the next state depends on the current state. So how the Qn plus 1 depends on the Qn when the input T. Basically, the T is the input. We'll be giving a single input in the T flip-flop. There is no double input like S or JK. The D and T will be having a single input. So when the input T is 0 and the current input is 0, obviously the next state is also 0. When the T is 0 and the current state is 1, and when the T is 0, the next state is as same as current state. When the T is 1, we'll be getting complement output. So Q will be giving uh the current state is I mean, the next state is complemented by the current state. Like when the t is 1, q is 0, qn plus 1 is 1. When the t is 1, qn is 0, qn is 1, qn plus 1 is 0. So we'll be getting a complementary for the q. And that is how the character table is. So this is the truth table. So 0. When the t is 0, q is 0. And q of t plus 1 is also 0. So when t is 0 and q is 1 and q bar is same. But when the t is 1, we'll be getting complement for the q as a next state. So q is 0 and q of t plus 1 is complementary for that. So 1, 1, when t is 1, q is 1 and the complement is 0. So when t is equals to 0, it's a whole state. When t is equals to 1, it's a toggle state because it is having a single input. So the excitation table is same. It's a bit different. So it tells what value t must be go from present state to the next state, and q of n is 0. Q of n plus 1 is 0. So t required output input is 0. When q of n is 0 and it needs to be complemented, and then the t needs to be the 1. When q of n is 1, it needs to be complemented. So the t required input is 1 and q of m plus 1 will be the complement of present state. So 0. T, when t is 0, the q of n is 1 and q of n plus 1 is also 1 because the input is 0, right? So this is how the t flip-flop timing diagram looks like. The clock begins with the positive edge, negative, positive, negative. and the t is 0, 1, 1, 0, 1. When t is 0, q is 0. When t is 1, q is 1. T is 1, q is 0. T is 0, q is 0. T is 1, q is 1. If we draw for a q, uh, um, so now the t is 0 and qn would be 1. Sorry, just a second. So t, the same happens here. This will be same. The t is 1. So this is also 0 because t is 1, which is in toggle state, and q is 1, and q bar would be complementary. Once complementary is 0. Now when the plot t is 1, q is 0, and then we'll be getting a peak here and then down, and again the same happens. Now it goes up, it uh, it goes up and it comes down, and we'll be getting two peaks here, peak 1 and peak 2, two peaks, like two ones we got here, q bar, and this is how the flip-flop timing diagram is. And yes, at each rising edge, t is equals to 0 and q holds, and t is equals to 1, q toggles. Just a sec. Yes. The characteristic equations of the T flip-flop are Q of n plus 1 is equals to plus of, it's not plus of, T XNOR of Qn. The plus with the holes, the plus with the circle along its own, like it's a plus along a circle with inscribes a plus is a symbol of exclusive OR where the like terms are 0. Like when the toggle is 1 and q of n is 1, and there will be no complementary. When input 1 is 1 and input 2 is 1, and the output would be 0, is when input is 1, input 2 is 1, and the output is 0 in the XOR. But this is exclusive OR, so the like terms are only ones. Like 0, 0 and 0, we'll be getting 1, 1, 1, 1, and we'll be getting 1. This is how the exclusive works. And the summary is like input, toggle, output, Q. The operation happens here is toggle or hold. Hold on. The characteristic equation is Q of n plus 1 plus T exclusive OR of Q of n, and the excitation table defines T needed for the desired next state. So basically 0, 0, 1, 1. There are two states but different Qn plus 1. These are all dependent upon the T required inputs, and the timing diagram shows the output changes with clock and time. And that's how the T flip-flop is like. And that's then. Thank you. Thank you for your attention.